Hi, this is Mr. T. This is Mr. Thomas about to review synthetic division, and this came from section 4.3. Synthetic division is a quick method of dividing polynomials. It can be used when the divisor is of the binomial form x minus c, and c is some, um, real number, integer, either a positive or negative whole number. Um, And so we have our first problem here. It says use synthetic division to divide 2x cubed minus 7x squared plus 5. One of the first things you need to understand is when you're dividing synthetic division, you must have, first of all, integer coefficients, positive and negative whole numbers. And we do. We have a positive 2, negative 7, and then our constant term is just positive 5. It has no variable. But also, we need our polynomial in the descending form. So the highest degree written first, in which case we do have. However, we're missing an x term. And so when you use synthetic division, you're actually going to have to um, write out that other term that we're missing. So the polynomial will really just be 2x cubed minus 7x squared. And then we don't have an x term, so we're going to just say plus 0x as a placeholder, and then plus 5. And now that we have it written out in this fashion, we can use synthetic division. We're dividing by x minus 3, and so in our case, that's like plugging in positive 3. And you have to ask yourself, what value of x will make this 0? And of course, positive 3. Or you can think of it as, what's the opposite of negative 3? Positive 3, right? Okay, and so we write positive 3, and then we're going to separate this from the line of coefficients here. So you write positive 3, and that came from this. And now we're going to put in the coefficients. So we get 2, negative 7, 0, and then 5. And so when you do synthetic division, you set it up like this. Always bring down that leading coefficient, that first coefficient, bring it straight down. And so we get 2. And now you do 3 times 2. What's 3 times 2? Well, 3 times 2 is just 6. So you put the 6 there, and now add. You always add. Negative 7 plus 6, negative 1. And now just add again. Multiply. 3 times negative 1 is negative 3. And now add. Well, you add with 0, you're still going to get negative 3. And now what's 3 times negative 3? We get negative 9. And now when we add, we get negative 4. And negative 4 is our remainder. And it turns out that 3 doesn't go in, x minus 3 rather, doesn't go in evenly. However, we still did it correctly. Now, we have the coefficients of our new polynomial, but because this polynomial has an x cubed, we're going to start with x squared. Okay, so our quotient is going to start with x squared. So we'll get 2x squared minus 1x, and then minus 3. And again, our remainder was negative 4. Another way to write this out, if they asked, was 2x squared minus x minus 3, and then minus 4 over what we divided by. Okay, this is sufficient as well. Let's do another example. Okay, so we're dividing in this case by x minus 2, so we're going to start with 2. And then we put in 1, 8, and negative 20. And now bring down the 1, and we get 1. What's 2 times 1? Just 2. Add, we get 10. 2 times 10? Positive 20. And when you add, we get 0. And this is great. Because we got 0, we know that this goes in evenly. X minus 2 goes in evenly to x squared plus 8x minus 2, 20. And so our new polynomial would be x plus 10. Okay. Another thing to note as well is that P of 2 is the value of the remainder. So if we plug in P of 2 into our function, if I substitute 2 into my function, I will get 0. In the same fashion in my other example, if I were to plug in 3 into my x, I would get negative 4 in the end. One more example, and this should be very instructive. So we have x minus 2 is being divided into x to the fourth minus x cubed plus x squared minus x plus 2. So we need to set this up. So first we're going to put a 2. Because we had a minus 2, we know it's the opposite sign. It's always just the opposite side. And then the coefficients are 1, negative 1, 1, negative 1. So we have 1, negative 1, 1, negative 1, and then 2. The first thing we do is bring down that 1. What's 2 times 1? 2. Let's add these together. We get 1. What's 2 times 1? 2. Let's add these two together. We get 3. What's 2 times 3? 6. Let's add them together. We get 5. What's 2 times 5? 10. Let's add them together. We get 12. 12 is our remainder, and my new polynomial would be, let's write it right up top here. It'd be, this polynomial starts with x to the fourth, so my new polynomial is always 1 degree less. X cubed plus, well, this 1 is positive. In fact, all the coefficients are positive. So I get just plus x, 1x squared plus 3x, and then plus just 5. And my remainder is 12. Okay, that's going to do it for this little installment. We're just going over synthetic division, and we will be back with more important theorems about polynomials shortly. Bye-bye.